last 3 months, because of COVID-19, schools have been shut. I hope that these materials that we present today will be beneficial to students in their final year of secondary or high school.
Hello everyone, you're welcome back to mathematics class, where I'm going to be taking you the topic trigonometry, and I'm going to be discussing on the cosine formula. If you remember in our last class, I told you that whenever you're about to solve anything that has to do with bearing and distance, or you want to do anything like angle of elevation and depression, you need these formulas, which is the Pythagoras theorem, the sine formula, and the cosine formula. And in our last class, we have already dealt with or treated the word Pythagoras theorem and the sine formula. And today, I'm going to be explaining how the cosine formula is being derived. Now, you know that cosine formula, just like sine formula, is used to solve the unknown in a triangles with the following dimension. That is, whenever you have a triangle and two sides with the angle between them is being given, then you are going to make use of cosine formula. Or in a triangle, if the three sides of the triangle are given, that simply means you are going to make use of what? Cosine formula. Now, two cases of proving the cosine formula is going to be considered in this discussion today. That is the acute angle triangle and the obtuse angle triangle. Now, looking at the diagram on this page right now, this is an acute angle triangle, while this is an obtuse angle. Now, this is, I told you in our last class that the capital letter A, B, and C is being represented by the angles that formed are the triangles, while the small letters are the sides. That is, anywhere the angle B is facing is your side B. Anywhere your angle C is facing is your side C. And anywhere your angle A is facing is your side A. Now, if you look at this acute angle triangle, we know that the total length of this C to B is what? Is A. That is where the A is facing. And let's take the line DB to be X. That is in figure 1. I tag this as figure 1 and I tag this obtuse as figure 2. So let's say that DB, line DB, let's give it X. That simply means if this one is X, that is the line DB, that means the remaining line CD is now going to be what? A minus X. If you look at the obtuse, line CD, if you look at the obtuse, this angle A is facing this side. That is the reason why line BC is our side A. And angle C is facing this side, which is, this side is the side C. Why the angle B is facing this side, which makes this one to be side B. Now, our line BC is what? Is A. That simply means if the whole length BD is not given, let us represent it with X. That simply means line CD is going to be what? X minus A. That's the reason why I said let line DB equal to X in figure 1 and let line BD equal to X in figure 2. So therefore, the line CD in figure 1, that is the line CD in this figure is going to be what? A minus X. And in figure 2, the line CD is going to be what? X minus A. Now, in triangle ABD, that is in this figure 1, if we make use of Pythagoras theorem, you know that anywhere our right angle triangle is facing is our hypotenuse. And this side, let us call it as our what? Our opposite side. That simply means in the triangle ABD, using Pythagoras theorem, that is hypotenuse squared equal to opposite squared plus adjacent squared. What is the hypotenuse squared? That is the C squared. Then equal to, what is the opposite? Opposite, because this is the acute angle we are talking about, which is angle B, is facing this line AD. That is the reason why line AD is the opposite, plus x squared, which is the adjacent. Then if we make use of line AD as the subject of the relation, we are going to have the hypotenuse, which is C squared minus S squared. That is equation 1. Then if you look at in triangle ACD, I'm referring to this triangle ACD. That simply means using Pythagoras theorem, we know that the hypotenuse, which is b squared, is equal to line AD squared, is equal to line AD squared plus a minus x squared, which means that is our line CD. That is the adjacent. Then we make use of line AD as a subject. We are going to have this b squared minus a minus x squared. Then that is equation 2. So from acute angle triangle, that is where we derive this. So if we now go to the obtuse angle, if we go to the obtuse angle triangle, if we go to the obtuse angle triangle here, we are going to have what? That is the same. Using this now, that is in the triangle ACD, that is going to be b squared equal to line AD squared, then plus what? CD squared, which is a minus x squared. So if you look at the relation between what we generated using Pythagoras theorem in triangle ACD, that is b squared minus a minus x squared, and b squared minus x minus a squared. If we relate it together, because line AD squared is equal to this, and line AD squared is equal to what we have here. So if we relate this one and this one together, we will note that they are the same. So note that in equation 2, b squared minus d is equal to this one, and you know that this b squared and b squared is going to go. That is, if we transfer this b squared to this point, it's going to be b squared minus b squared, which will give us 0. And negative will cancel negative. Then if we expand this, and you expand what you have here at the right hand side, you will notice that at the end of the day, you are going to have 0. So now, if we're not equating equation 1 and 2, that is the equation 1, which is what? C squared minus s squared, and the equation 2, which is b squared minus open bracket a minus s squared. If we equate it together, then we are going to have what we have here. Then we are now going to expand. If we expand what we have here at the right hand side, a minus s squared, we're going to have what we have here. Then after expansion, we're going to just collect what it is being needed. And you know that minus s squared at this point, and if we can transfer this minus s squared to this side, that simply means they are going to cancel. Then c squared equal to b squared minus a squared plus 2ax. So that simply means we are going to make use of 2ax as the subject of the relation, which we are now going to have this equation 3. So if you know that in our diagram, you know that we have line in triangle ABD. We are going to make use of x as the subject of the formula. That is, you know that this side, that is angle B, which is the acute, is facing the line AD. If you are to use this side, we have the hypotenuse side, and the adjacent side is being given, which simply means we are going to make use of CAR, which is adjacent over hypotenuse. That's the reason why we have x over c. If we cross multiply, we will find our x, and we tag this our x as equation 4. If we now substitute this equation 4 into equation 3, we are going to have 2ac cos b equal to a squared minus b squared plus c squared. And if we divide all through by 2ac, we're going to have cos b equal to a squared minus b squared plus c squared over a squared. Similarly, if we have something like this, that is, we generated cos b equal to what we have here, that simply means our cos a will also give us what we have here, and also our cos c will give us this. Hence, from here, if we make a squared as the subject of the relation, by cross multiplying here, at the end of the day, we're going to have a squared equal to b squared plus c squared minus 2bc cos a, and b squared equals to what we have here, and also c squared equal to what we have here. So whenever you have any challenges in calculating any triangles, any given equation in any triangles, whether you want to calculate the angles or you want to calculate the sides, so you're going to make use of this cosine formula. Thank you for listening. I wish you the very best. In our next class, we are still going to discuss further on more examples. Thank you.